Good morning. Alright, so we are going to complete all the repairs today. Hopefully our vacuum looks good. It is approximately, there you go, it's 10 degrees, 51.2 degrees Fahrenheit for those of you who check temperature in Fahrenheit. We do degrees Celsius. Yeah, all scanned in, temperature checked, sanitized, and we are ready to go. So yeah, let's go and have a look and see what that vacuum looks like. Okay, let's have a look. Here we go. Right, I think we can do a decay test. Yeah, probably just for a short while, but we are looking good. 270 microns. Yeah, that looks real good. I'm happy with that. Cool. Alright guys, so what I'm busy doing right now, like I said, I'm watching Young HVAC, shout out. At the same time, like I said, this client has got a remote setup. I just need to install the software real quick on my laptop, set it up, and I'm definitely going to have to deactivate the lock modes because they got the system locked in heating. So once the system or the setup is installed, I'll configure it and sign in, and then we can get this thing going. So yeah, much less, one technician at a time. So Young HVAC talking about 10 things about the industry, which initially was posted by HVACR blogger. So I recommend you guys check that out. Okay guys, so we were able to deactivate the limit that was set on the system. It was basically limiting it only to a heating mode. We removed that limit and we are now functioning in test operation, which is in the cooling mode. Let's have a look. That's why you'll see the set points are all set to 3 degrees. And the reason that is so that the system doesn't satisfy or cycle out on temperature, so that if we do need to add additional gas, we can do so. So the system is in safety start, operation mode is in cooling, so all of that looks good. And we can now have a look at our temperatures right here and pressures as well. So just off the bat, we know we're a little bit low, so we're gonna add additional charge to the system. The base charge is 8.4 kilograms and the additional charge is 18.8. So we just need to add a few more kgs, and you can see, so these saturated temperatures right here is calculated, so that's not measured by a physical sensor. So I'm not too worried about that. Like I said, we're going to give the system 15 minutes to stabilize before we start looking at the numbers. So this is just a diagram of the entire outdoor section. We can see compressor 1 is running, compressor 2 is still off. Now the pressures are quite low at this stage, but I'm not worried about that. We just started up the unit, so let's give it 15 minutes and I'll get back to you guys. Cool. at 10.85. We've got about 805 grams or 850 grams to add in, then we should be on the charge. So let's just go through this condenser quickly if you are unfamiliar with the system. So one of the things that stands out in this unit is really, and things that you need to check, we got some frost on the suction side. It's dropping, so that's fine. We're not flooding back to the compressor, so that's fine. Here's our compressor suction side. Discharge right here, as you can see, it's a 20 horsepower system, and this right here is our vapor injection. So yeah, we've got our two EVI solenoid valves which run on this line. So this is a cool vapor line, as you can see over here from our suction accumulator. We've got another solenoid valve, but really it happens down here. So that right there is our intercooler, and we've got an expansion valve on that as well. And that same line from the intercooler gets fed this way, and it comes through the back here. So instead of having your heat sink where you draw from your fan motors or drawing ambient air to cool down the inverter power module, what Samsung did here is they've got a cool vapor line cooling the inverter boards right here. So yeah, that's a cool vapor line. Same with the EVI, your vapor injection into the compressor, just to manage air temperature. So once we're happy with everything, what is very important is that we check this valve right here for proper function. This is our accumulator return valve, which returns oil back to the suction side, returning it back to the compressors. At the same time, I don't know if you'll be able to see, but down there would be our oil separators and the capillary. So checking your temperature differential is very important. The same goes for checking your temperature differential on the accumulator return valve. So luckily for us, we've got clamps. We can put the clamps on here and actually get an accurate measurement. So the way of doing that would be, what the manufacturer recommends is, while the system is running, because when it runs in a cooling mode, that valve is permanently open. So right now we're going to disconnect it, and what they recommend is you give it some time, and you should feel a temperature difference across. You give it about 5 minutes or so, and then you'll plug it back in and then feel the temperature difference across the two pipes again. Like I said, we do have clamps, so we'll do that so that we can actually get an accurate measurement on the temperature difference across the accumulator return valve. So yeah, that's pretty much the system. We're nearly there. The other thing that's very nice, if you have a look here, we've got a P072 error code. Now, what I really like about this system is, if we go to the top here and we go to help, if you're not familiar with the error codes, everything is listed right here. So take it out, we know that's about 700. We go to E701, and there we have it, E702. EEV, electronic expansion valve, in the indoor unit cannot open fully or properly, first detection. So first detection is like it's more like a warning. When there's a second detection, it will switch the indoor unit off completely. As well, if you're working on the outdoor unit, all those error codes are listed over here. which I think is quite convenient, along with a bunch of other functions. Like you saw, we put the system in vacuum mode, and one of the other things that we'll more than likely do is change the oil return cycle. We'll probably reduce that to half. So yeah, I think that's pretty handy. So all in all, everything is looking fantastic. Things are looking great, and I think we're about ready to have a look at the heating cycle, make sure that everything's functioning correctly. But so far everything's looking great, so yeah. Okay guys, so I just spoke to one of the technicians at Samsung, and they recommended that I run the rest of the system on cooling, and the 2 units that's giving us an issue, run them on fan only for about 10-15 minutes, just until our sensors basically equalize to our room temp, and after 10-15 minutes change to a cooling mode. That way we can verify whether or not we've got sensors that are restricting the electronic expansion valve from opening in a cooling cycle. So yeah, we're just going to verify that, just to make sure that everything's working 100%. Alright, I'll give you guys a preview of what I'm busy with. So this is what I'm doing right now. Like I said, they have these units linked up to their DVMS, which enables remote access. So the system that we're working on is the West system. So we'll go to West. As you can see, they're all on heat. So we'll say select all, and then at the bottom here we'll select cool, and then we'll put it on cool mode as well, and that should now change all of them. And this condenser is running right here, and there we go. There the system stopped, and it will basically restart the entire unit. Yep. So now we'll wait, and we'll start up the rest of the system in cooling mode and check that 2 units to verify whether or not we need to change the evaporator in and out sensors. So I'll give you guys some footage on my service checker. So there's my service checker. So this is the online setup. As you can see, I'm in my Internet Explorer, but if I scroll down and over here, this is my service checker right here. So you can see the operation mode stopped. I'm going to go to firstly I'm going to go to window unit data, and I can see everything has stopped. Indoor units are still on though, so we'll go to control, select all, cool, and press on, and there, as you can see, everything is starting to change from a heat to a cool mode. Then I'll say unselect, and that one specifically I'll put on fan only. Alright, so I'll close that, and as you can see, the rest of the systems are all on cool. The top one is on fan only, and we're going to verify that this EVA in and EVA out sensors are not causing our EEV, electronic expansion valve, to open in cooling mode. So in heating mode it works perfectly fine, but in cooling mode we seem to be having some issues, so we are going to verify that. Okay guys, so this is very interesting. So we went ahead and switched the system on cooling, The top system over here, which is address number 0, that one was giving us issues. Now we've got that system on fan mode only at the moment. Now if you have a look at the room temperature right on top, it's at 25.3 degrees. Our evaporator in temperature is 24.7. But the interesting thing is the evaporator out temperature is on 9 degrees. So that's a very interesting result that we have so far. The recommendation was that we run the system like this for about 10 to 15 minutes, and once we waited for that period, we will then reinstate this unit that's on fan only and put it on cooling and see how that changes the sensor values, because that could be causing our electronic expansion valve to be acting erratically. I mean, you can see the temperature difference between in and out. There's about a 13 degree difference, and our expansion valve is completely closed. So that's interesting. Okay, so it's been about 10 minutes. We've switched system address 0 and 1 on cooling. As you can see, there is cooling capacity, and the expansion valves have started opening as well. The biggest change I can already see is on address number 1, which would be the ductless midwall. We've got 16.4 incoming, 22 outgoing, and the room temperature is dropping as well. We are starting to see a small drop on address number 0, which is the cassette, the 4-way blower, but very minimal. So we're going to give it another 5 minutes to run and then see if there's any changes. We just have a look at our outdoor data. That doesn't seem right. Let's give it some time to stabilize before we jump to any conclusions. But that pressures just seem way too low, so we'll give it some time and see what happens. That's the thing about these VRF systems, guys. Your manifold gauges mean nothing. If you don't have a service checker, you won't be able to properly diagnose these systems. So yeah, it's pointless I even try and put my gauges on, because it's not going to give me an accurate measurement of what's actually happening in the system. So it's really important that you are able to analyze the system data to see whether or not we've got an issue. Interesting. We basically equalized room temp, evaporator in and evaporator out, yet the expansion valve made about 258 steps. Our room temperature on the second unit hasn't changed much. It's still been on 20.4, although we have a 4 degree difference on our evaporator. This is crazy right here. this is basically why our suction pressure and high pressure drops so quickly, because we're satisfied. Our room temps are all within 1 or 2 degrees from our set point. So all of these units, all the expansion valves, they basically closed up and they're starting to open up again. So let's have a look and see. But still, there isn't a big difference on those first units there, and that room temperature is still at 24.2. That one is still at 20.3. So there's nothing happening on that evaporator coils.